They said God created the world in 7 days, but God didn't have legacy code standing between him and success.
And speaking about standing between, we know that we are the only one standing between you and lunch. So let's get started with the presentation.
Uh, N-am un clicker. Okay, we're gonna do it old school. Today we're gonna talk about just a brush up on what's a monolith, what's a microservice, these buzzwords. What is modularization? How do you use it? Why you use it? How exactly did we use these concepts in our own scenario, in our own application? What we learned from that, and hopefully we'll have a bit of time for some Q&A. But before doing that, you know who we are, but we don't know you. Can you pull up your phones and either scan that or just go to Menti and use that code there and tell us who you are? Okay, a lot of technical people in the room. In that case, we will try not to bore you that much with the theory. We're just gonna touch a bit upon some subjects and then actually get to it. So I mentioned that we're gonna talk about monoliths and microservices. What exactly is a monolith? When people say monolith, they usually think of something big, something large, something glacial. Let's take this example. Let's say this is our monolith for today. And there's a really nice long definition there of what is a monolith architecture, singular large computing network, one code base, couples all the business concerns together. Okay, let's break that down in English. So, what does exactly that definition mean? If we take a simple example, just say that we have an application, a shopping application where we have an inventory, we have a shopping cart, we have payment, and let's apply that definition to that. We're talking about something that runs on a single instance, something that is big, large code base, everything put here together. All the layers, application, data model, business layer, everything is running there. And usually in practice, that means a really long service with a lot of lines of codes that does everything, unfortunately.
Okay, now that you have seen what is a monolith, let's try to answer another question. What are microservices? And if I were to provide a definition, I would say that a microservice represents an architectural design that relies on a series of independently deployable services. But what does that definition actually mean? And let's take the same analogy with the Rubik cube. So each mini cube from this giant monolith represents a microservice, and this is because each mini cube has its own business goal, has its own database, has its own business logic behind the scene. So I would say that each action that we can perform on a microservice is specific to every single microservice from our architecture. So testing, updating, scaling, deployment, all these actions are specific to each microservice. More than this, we would say that microservices are responsible of decoupling major business concerns into smaller pieces, into smaller code bases that can run independently of each other, but they all contribute to the overall application. So let's take the same example that we have previously seen for the monolith, the same shopping cart application example. but look at it this time in comparison with the microservice application. So instead of having a single instance that contains 3 different functionalities, we will actually have a collection of individual, loosely coupled components named microservices that each has a specific goal. And we get to this collection of microservices by applying the single responsibility principle. And yes, if you think at solid principle, they do apply to microservices. So by applying the single responsibility principle for this sort of applications, we will get that collection of microservices. And now that you have seen what are both a monolith and a microservice, let's try to do a small exercise. So on this slide, we have a list of 8 advantages for microservices and monoliths. And we will switch now to a small quiz. So please pick up your phones, scan the next QR that will appear in a couple of seconds on the slide. And while we get to that QR code, let me explain what you will have to do. Okay, we'll get that soon. So once you'll scan the QR, that will be available, and it is available, so please scan it. And once you connect, you will see that 8 advantages, but please remember they are common for both monoliths and microservice. And the exercise consists in selecting only 4 advantages that you think are specific for microservices. So please select those 4 advantages that you think are for microservices. Okay. Let's see, what do you think about this? Results are starting to come. Okay. Okay, and I think that time's up. And you still continue to provide answers. Okay. Now, let's switch and see what were the right answers, what you should have selected. So, for the microservices, they are highly maintainable. They are characterized by the fact that we have improved fault isolation. From the technology perspective, they are very flexible, and also they are smaller and faster to test. Now let's switch back and see what you have answered and see what we have to discuss. Okay, so there are quite a lot of responses for the easy debugging. Let's take that one as example. So let's think about the monoliths now. A monolith, as my colleague Cătălina mentioned previously, they have a single shared code base. So the entire application runs within a single process, within a single memory space. So to follow a request, to follow an issue, it's just a matter of tracking it out through that process. We don't have to track that issue for several microservices. So this is why easy debugging is more specifically for a monolith rather than a microservice. Okay, let's do the same exercise now for the disadvantages, because, okay, microservices do offer a lot of advantages, but they also have some consequences, some disadvantages. So, same exercise. We still have 8 disadvantages this time, 4 specific for monoliths, 4 specific for microservices. And now let's switch. Same QR code, please scan it. And let's see what you select from that list. What do you think are the disadvantages of the microservices? Okay, and let's see the answers when they are coming. Okay, only a few. Let's wait a bit more. Okay, time's up again. Let's switch and see what should have been the answers that you should have selected. So for the microservices, the disadvantages are regarding the software sprawl, regarding the infrastructure cost, increased memory consumption, And lastly, distributed security and testing. Now let's take a look a bit about what you have answered. Okay, a couple of you selected. Let's take, for example, maintenance. Okay, it could be a disadvantage of microservices. Indeed, they do have some disadvantages from the maintenance perspective. But let's think about a monolith again in comparison with the microservices. So if we have to update one module, one small services from our monolith, we have to redeploy the entire application. For the microservices, we just update and redeploy that specific microservice that we are updating. So this is why it's a disadvantage for the monoliths and not for the microservice. Okay, now that we have seen what are monoliths, microservices, what are their pros and cons, let's see what do we do with this information.
What we do with this information is we introduce another buzzword. We modularize. We say that modularization is the backbone of microservice architecture. So if we were to put a motto on microservices, one module, one responsibility. If we take those two examples there, each one of them has to do a single thing. Only payment, only checkout, not everything put together. One single responsibility. How do we measure how good a module is? We measure it by using coupling and cohesion. So what are coupling and cohesion? Except buzzwords. We say that coupling is the degree of interdependence between the modules. So if we put coupling in that drawing there, it's how dependent module 1 is to module 2 and the other way around. A good module has low coupling. We don't want interdependencies between two modules since they are supposed to do different separate things. So what is cohesion? If we said that coupling is between modules, well, cohesion is inside modules. Is basically the degree of interdependence between all the components inside the module. Is, if you want, the glue that keeps that module together. All those functions have to work towards the single responsibility of each module. So it's that. We learned what is modularization, but in what scenarios do we use modularization?
And even more, why would we want to modularize everything? Why would we want to break down the monolith? And if you're still not convinced from our previously example, from the advantages and disadvantages for both architecture, let's try to answer this question. Why would we want to modularize? Well, the answer is that basically monoliths have different types of problems. So bringing a feature to the market, for example, takes a lot of time. Fixing a defect in a monolith takes a lot of time. And not to speak about the fact that sometimes when we implement a new functionality, we break something that was working for years. But let's elaborate even more on this. So let's try to answer a question. Is monolith flexible? Well, the answer is no, not quite. And this is because the technology stack is decided at the early stage of developing that monolith. So it is difficult to update to a specific version for a specific technology stack in a monolith, let alone to incrementally adopt a newer technology stack. How about, is monolith reliable? The answer is still the same. No, not quite. And this is because if one module, if one functionality goes down, the entire application may go down. Let's speak about development speed. I already mentioned that fixing a defect takes a lot of time. Building for a small change that you have performed takes a lot of time. And how about onboarding a new member that just comes to the team and has to learn the entire architecture of that application, of that monolith, before starting to make changes that may break something in that monolith? How about building complex application? Imagine that you have some dependencies, some modules, some functionalities that only work on Windows, and you are asked to deploy your monolith and put it on Kubernetes. You have to do some workarounds there. How about scalability? While it is true that a monolith can be scaled if we think that we can have multiple copies of the same application and a load balancer, we still have a lot to configure then. And let's think about the microservices. They offer the possibility of only horizontal scale that specific microservice that we need and not the entire application. And lastly, how about continuous deployment? Well, monoliths are an obstacle to frequent deployments. If we have to update one component, we have to redeploy the entire application. So how? How can we achieve this? How can we break down the monolith? How can we modularize everything? And the right answer, the honest answer is that it's going to be a difficult and a long process. And this is because monoliths don't have a proper separation of concerns. So any migration strategy that we may adopt to modularize, to break down our monolith, will have to allow teams to incrementally refactor that application into smaller modules, so to create microservices, but those microservices that we are refactoring have to provide functionality to the users, and they still have to be extended, so we have to provide new functionalities. So there are three major steps that we need to take into account. First of all, we need to stop extending the monolith. We have to stop adding the new functionalities to that monolith and make it even bigger. Secondly, all those new functionalities have to be created directly as new microservices. And lastly, we still have to take into consideration that we need to decouple and create those microservices from the old architecture. And let's take the same example that we have seen so far, the one with the shopping cart application. So how do we get from this monolith example to a microservice architecture? So first of all, we need to apply that single responsibility principle that I was telling you about. So we have to analyze the functionalities. And if we look at this small example, this theoretical example, we already have a payment functionality, we have a shopping cart, and an inventory. So we need for these three, let's take only these three as examples, we need to define what are the boundaries, how they communicate with each other, how they communicate with other. And once we have this settled, then we can start actually creating entity services and get to the point in which we say that we created the microservices. And I would say now that enough with the theory and this example with the shopping cart. Let's see what was our story.
And in order to get rid of the theoretical examples, I want to get rid of this monolith. Who's brave enough to take it away from me? Thank you. That was easy. See how easy it is to break down the monolith? You just move the responsibility to someone else. This is the part where our actual confession starts, where we were and what we did. We have a single server release application. That is our monolith. Our monolith can be deployed on Windows, on a single server Windows. And we said we want to take our monolith and we want to bring it into the cloud world and we want to deploy it in a cluster. So we introduced an idea of a server cluster release that can run on Linux on a Kubernetes cluster. Great, so how do you get from there to there, from Windows to Linux, from single server to microservices and the cluster? One option is to just start from scratch. You know the business of that, just start developing another project on the side, work on that for years, hope that your microservices won't actually become legacy until you manage to release that to production. Another option which we're trying out, which we decided on, is to change the engine while flying. use the same services, use the same code base, and then make the difference when you deploy, which is not easy either. Let's zoom in a bit on how exactly did our architecture look like. On the single server deployment, to give you a bit of history here, a while ago, few years ago, when we made the change from our major version back then to a new major version, our application went through not a modularization process, but a changing of what exactly our architecture is as well. And my ex-colleagues from back then, a long time ago, we're talking about an application that has been in production more than 20 years, so that means a lot of major versions along the way, and an application that is used in military deployments, so a critical application. My ex-colleagues back then said, we need to prioritize. How are we changing the architecture of this? They had back then a .NET server, this one here, and they also had a .NET client. And they decided that they want to move to a world where the architecture is a client-server based on a browser. It's working on Chrome right now. And what did they say? Okay, in order to get that, we can't take our .NET client and put it in a browser. That's impossible to do. Great, we're prioritizing the client, we're creating a new client. But we can't move everything. We have to prioritize something. So they did a really, really, really pretty client, that one there, and they ended up with this. And this was composed of the old .NET server, which became our legacy server, a new shiny Java server, which became the new world where the plan was to put all the features there, everything new is going there. And these two servers need to talk to each other, right? Synchronize stuff, certificates, data, and so on. So they put in the middle a legacy transition server. And you get that with a lot of soap calls from one to another. But with such a beautiful client, awesome. How do you move that to cloud? First of all, you don't move it to cloud in that way, because you can never run this on cloud. So let's get rid of legacy. And if we get rid of legacy, if we get rid of that old .NET server, then that means we don't need the intermediary step either. And here it's starting to look manageable. We have one server, we have all our business logic in a single place, and remember, we have the really pretty client. Let's take that, let's put it on a cluster where we have multiple nodes and that server somewhere on a single node where the legacy server runs. And let's start introducing scalability to this. Let's start introducing microservices that can actually scale across all these multiple nodes. Keep the legacy for a while, make it smaller, make it go away. We had a lot of constraints along the way, a lot of issues that we ran into. We're gonna tell you the major ones that we confronted ourselves with, but if you scan the code, you can also share with us what do you think your constraints would be in that scenario, or if you were in a similar scenario and you want to share your experience with us, we're gonna take the questions and comments later on.
Okay, so this is just an open question. This time we don't have a test, a quiz, anything. It's not an exercise, it's just something that you will share with us and we will discuss it afterwards. And in the meantime, let us share what were our main constraints. So you have seen our general architecture, our high-level architecture, where we were and where we wanted to get to. But along the way, we had several constraints. And first of all was regarding the support for Windows. So our clients are from the military domain. They run on Windows, and we needed to still ensure support for single server deployment on Windows. And let's take an example, a specific example that we have faced. So we wanted to have support for Windows. We had the notification service that was working perfectly there. Afterwards, we said that, okay, now we want to extend it and have Linux, to provide support for Linux for those users, for those customers that were requesting this. And what we have done, in parallel with our service that was working correctly, we started to implement a newer service, a newer notification services with a new technology stack. We used Kafka. And when we merged our work, and we were under pressure, so there were some constraints, budget, deadlines, we had to deliver something. We identified that our new notification service, shiny new Kafka notification service, didn't work properly on Windows, didn't work at all, actually. So what did we have to do? We implemented an abstraction platform. So basically we have a switch in our application that switches between the old notification service that is still working correctly for the single server deployment on Windows, and for the cluster setup, for the Linux setup, we switched to that new notification service. This was the first one. Afterwards, we noticed that we started to modularize feature that customers asked us to extend. So we had to apply some workarounds because we didn't manage to finish in a single release to modularize everything, to migrate everything. So first of all, we applied the branching strategy. So we had different build pipelines internally, one that contained our modularization, our migration, and one that contains the new features. And we had to maintain both of them. We had to apply the same fixes for both of them. Secondly, we had to extend our automation test so that we ensure that we are not breaking the old functionalities. The old code still had to work correctly, even though we were migrating it. And lastly, we still followed every principle for the continuous integration and deployment scenarios, even though we were releasing internally on that different branch strategy. And this was our second one. And another one, stakeholder management, this was actually very interesting, and it was one of the first constraints we have. So what did the stakeholder management ask us to do? They wanted performance. They asked us to do something to have a performant application. They wanted scalability, so they asked us to have that application to be scalable and performant. What we have asked for is modularization. And we were forced to explain to them, to provide as much examples and a lot of discussions to convince them that we actually need to start with modularization. That will get them scalability and performance, and not the other way around. They said, let's prioritize performance, and afterwards we can talk about modularization. And we had to explain that, no, it's the other way around. And another constraint was about the technology gap. So we wanted everything that was new on the market. All the new technology that we have read about that were on our radar, we wanted all of them. But we had to start analyze and identify what actually brings some value for us. We didn't want to just overpopulate everything. And also, we had to learn how to use them while still working on them and meeting deadlines and other constraints. And to sum up, these were our constraints. And now let's see if we have something from your side. Cătălina, if you can help me with this.
Yes, I actually see only one participant and one answer.
Okay.
Was there a technical issue or something?
When you scan the QR code, it takes you to the first question that was asked in the presentation. Like, what is your current role? Okay, so maybe...
Okay, shall we try again?
Okay, we can take a few more minutes.
Can you try it again?
And do you get this time to the right question? Perfect.
And we can take the,
The first one.
yes, people and new technology stack and deployment.
Yes, yes. New technology stack. We also have had to learn. We have faced the same. So we had to learn the new technology stack. We wanted what was new, but we had some training to do first on it, and still meeting the deadlines and budget constraints and all this stuff. Hopefully you're referring to the same. Otherwise, we can discuss.
What about management and business needs?
I think you're referring to the same situation that we have mentioned. We needed to obtain to convince them about budget. We need budget to modularize, and if we achieve that one, it will get them those business needs for scalability and for performance.
It's a really interesting one. How do you manage to embrace the change?
Yes, that is quite interesting. Yes. Yes, you have to convince everyone. You have to convince all your teams, all your management, all your clients that change is good, and we have a lot of benefits from this. Okay, so thank you for your feedback. We can discuss even more in the Q&A session about this one. And now let's see what was our journey.
As in every journey, it starts with an idea. It starts with someone getting to that frustration point and saying, I can't work like that anymore, and I have an idea to actually change how we're doing things, and I know where we need to get. And what do you do with that idea? Well, you know the final destination, but you need to break down your idea into pieces, small enough pieces that can be seen as goals, and you define each goal as you go along, and each goal has to work towards getting to that final destination, getting to that idea you had at 3 a.m. in the morning where you said, I can't work like this anymore. And what do you do with those goals? You design them. A lot of us are technical here, and diagrams are the basis of our work each day. You start with the architecture you have, you start with the architecture you want to get to, and then you put a lot of transition architectures in between, and then you take a step back and you look at your whiteboard and all the walls around that whiteboard, and you say, I need even more transition diagrams, and you get to a point where you know exactly the steps, you know exactly what you need to do, you're sure enough of your idea and yourself, and you take that dream and you go to stakeholders. Because someone has to approve that and someone has to pay you to do that. And what do stakeholders do? Well, stakeholders look at your awesome idea and all the steps that you were so sure about and say, nah, there is something there that you haven't thought about. And you take that something and it's back to the drawing board, and you keep this loop until at one point you get the Christmas miracle and the stakeholders don't find anything, any piece that you haven't thought about, and they said, yeah, let's do this. Let's plan this. We can do it. Plan leads to actual development. You start implementing your idea step by step. You're getting closer to what you want. And then you merge it, and then you get into production, and then you stumble. Because, okay, you didn't find any issue with your plan. Stakeholders didn't find any issue with your plan. But when you go from plan to actual coding and to actual reality, sometimes things don't work as planned. And you're back, you develop, you stumble, you develop, you stumble a bunch of times until finally you adapt. You fix everything, you have enough auto tests in place to say that, okay, we moved the legacy and now it does the same thing, and on top of that, we did all these scalable microservices and we adapted our needs and we found the constraints and we overcame the constraints and we finally got success. That was the steps we went through. And every time we stumbled, or every time a stakeholder said something was missing from our plan, we learned something. And we're gonna tell you the 4 major lessons we got from this journey. There are a lot of lessons, but we try to prioritize again, only 4 of them. One of them is that you start with a noble idea. This is what every developer wants. I'm gonna modularize everything. And then reality hits you. I'm not gonna modularize everything anymore. I'm gonna prioritize what I modularize. Another lesson is we all hate legacy. Let's get rid of legacy. And the funny thing about legacy is that legacy is by definition something old. Probably the people that actually wrote that code are no longer in your company. You have no idea who to ask. So yeah, good luck getting rid of legacy. Good luck migrating a old 10-year-old .NET server and trying to keep the business logic intact and hoping that someone documented a line of code that explains what the heck that is, and they didn't document it with if it works, don't break it. And you hope that you have enough auto tests in place and you have a long enough system test, and someone will catch that when you just go to the first page and nothing works anymore. Yeah, you hope you don't get to that. What else did we learn?
Yeah, what else? So, in our monolith, there were several hidden monoliths. So we had to learn when to stop, when micro becomes to micro. We didn't want to create a microservice at a method level. So we had to define some boundaries, we then needed to identify them correctly, and we had to extract from the microservices best practices recommendation only what suited us. And regarding those monoliths hidden inside other monoliths, we had to prioritize what needs to be extended, what are the bottlenecks, what needs to be scaled out for our customers. And we had to prioritize with what services to start, what functionalities. And another lessons that we have learned, and I already mentioned this one, deadlines are a real thing. And because of them, and budget constraints as well, we had to prioritize. And we already told you earlier that firstly, some time ago, we prioritized the front end. But front end doesn't mean that it was perfect either. So when we prioritized the server side, we started a new module. We used the new Spring Boot framework with everything that brings new. It was easy to create it and develop it. But when we merged it with our client side, we actually had an old GSP page that calls correctly the new Spring Boot application. And yes, everything worked perfectly, but we do have an old GSP page that calls Spring Boot pages. So imperfections exist, and they exist because we had deadlines and different constraints, time and budget. And to sum up,
we're gonna leave you with one thought. Yeah, that's how it started. But jokes aside, this is a reality that a lot of us are facing. A lot of the applications that are used currently in the market have been around for years, and they have legacy code, they have maybe something worse than a GSP page. And yeah, I hope that what we presented today is something that helps you in your scenario. Not all of us have the luxury to start from scratch on a project. Not all of us have the luxury to work on microservices in a new project. And even in that scenario, how long does it take until that project becomes legacy? Yeah. We have a couple of minutes for questions before we all run to lunch. If anybody has questions. Yes?
How did you handle the database breakup?
So you're asking about the database breakout. We had that old .NET server that had its own database, and we had the Java server that also had its new database. And we had scenarios where we had fields for the same model. We had fields in one database and fields in another. Okay, sounds familiar.
And how did you synchronize between them? You join.
It was a complete hell to synchronize between them. We had certificates between the two servers, and those servers talk continuously, and they have the three-way handshake in between them and so on. And every time you did, for example, an export, you were exporting in a big block fields in one database, fields in the other database, and you were hoping that both of them work. And if they didn't, your entire export would fail. And you would have to at least make sure that you clean up, and you clean up in both databases. And we've been working like that for years. And when we moved that .NET server, that's where we started as well. Let's take these fields, let's move them to the new database, and let's make sure that actually they're not duplicated. We had that case for something where we duplicated fields in one database and the other. So get rid of legacy means also get rid of database, otherwise you're gonna be stuck in the same place in production. Don't try to synchronize between them. Never works. Okay, other questions? Yes?
Did you notice any performance decrease with the feature in a microservice compared to the one in the monolith?
At the beginning, yes. So the first service that we have migrated, we discovered that actually on .NET it ran faster, and we had to review our strategy to see where we made mistakes, and it was actually our fault. Because, for example, Hibernate from .NET worked faster than our own solution, and we had to adjust until we got better results. But we got to that point with several workarounds and redesign. Okay. Yes.
How do our microservices interact? We had a slide at one point with some technologies. So our Kubernetes cluster comes with a bunch of stuff like Istio that we use for traffic monitoring and security inside and outside the cluster. That was one. We use notifications. We used notifications in the single server as well, but now we introduced Kafka queues for the notifications. Yeah. And we're trying not to make other workarounds. We're trying to use the third parties that were built for that purpose, not to do custom in-house stuff. Okay. Yes. It's a long process. I can tell you that the first design was actually done 1.5 years ago, but the first line of code in this direction was written last fall, back in October. And we are taking 1 year of development, only development, until we're bringing to production our alpha version. So for our alpha version, we did what Mihaela presented with trying to identify the monoliths inside the monoliths. We ended up right now with, or we are in development actually until fall, with 2 scalable services that were bottlenecks before. One of them is our notification broker, and 6 separate containers.
Yeah, but for sure we will have more
Yes,
in a couple of months.
this is the beginning.
Yes.
Yes, this is our first iteration, our MVP. Just kick it out the door, put it in production, wait for the defects while we have a really big backlog. Okay,
Anything else?
yes.
Going to ask a question that probably the stakeholders already asked you. Why couldn't you use .NET Core? Why did you need to rewrite the application instead of just, I don't know.
We actually tried with .NET Core as well, and what .NET Core did for us was that we managed to put our legacy server on Linux. But our architecture was still a mess. You still had the Java server, you still had the .NET server, and you still had the legacy.
Yeah,
The
but you could
one.
couple, extract the microservices, and then migrate one microservice at a time.
That could have been a strategy, yes. Our biggest pain was the way these whole servers have to talk with each other. And the fact that you have to work in .NET now, and after lunch you have a feature in Java, and tomorrow morning you're back to C# and so on. And it was a mess for developers. It became frustrating for developers to build in a way, you develop in another way, and keep switching between this. And that's why we wanted to go only towards Java, and we wanted to get rid of C#, which I have to admit it might be a personal choice, but in our development team it wasn't anybody's choice. So it came as an internal goal as well. Okay. If there are no more questions, then to sum up, today we brushed up on what is a monolith, what is a microservice, how do you use modularization, how we used these concepts, where we are now, and what we learned from that. And I hope you're leaving this room with some knowledge that might help you. And if you have other questions for us, or if you just want to share your experience with us, we're going to be at the systematic stand for the rest of the day. Thank you all.
Thank you.